Hi everyone. Uh, we talk about basically in this session. It's a lab session, a practical session. I think we have already covered HBase Java client application. Here we talk about HBase. It's a Java MapReduce program. So here, basically, your file, the input file, is in HDFS, and we write a MapReduce program that reads a file from Hadoop HDFS and write it into an HBase table. So here, probably if the file is big, I think what happens in a MapReduce program, the split, and each mapper will process the split of the data, and in parallel, data will be inserted into an HBase table. So all the processing will be taken care by Hadoop. We need not write anything in the code that handles the doing things in parallel, because this is basically Java MapReduce program. So that's what we're going to cover in this Java MapReduce program. And here there is a no reduce involved here, because here we are not calculating any aggregates, and even we are not trying to insert aggregated data from a row level data. Here basically what you have is a simple uh, data in a flat file, and there's no reducer involved. Whatever is there in the flat file, just we insert into our HBase table. So here we have to write only the driver program and a mapper class, right? So we need not write any reduce class. So what to write is a mapper class, yeah, that reads, of course, everything will be taken care based on input format, that parse data and write into HBase output format. And next thing is a driver class. And before I walk through the source code, let's go through what's the input file we use and where we write the output, and then walk you through the code. Right? I think we always follow our standard. I think I've already copied my input files into HDFS as well. Let me check it. HD. Right, and just give me 1 minute. Excuse me. So all daemons are running, both Hadoop as well as HDFS, and we can always check it. JPS, everything running. Right, we're running for HBase, HMaster, HReason server, HQuorum pair, and also daemons related to HDFS, data node, name node, node manager, and resource manager. Right, and we always follow our the standards. We always keep our files in this directory. Let's go to there, cd vi, I think vi, right? And whatever the input files require, everything we copy it into this location. Let me, I think HBase, yeah, I think here I have not created a specific folder for the HBase MapReduce, because I think I'm using one of the file. I am using the employee file here. That is why I'm not maintaining in my Edge node. For us, everything is same, but I'm not maintaining this folder in HDFS. Sorry, in Edge node. But I think we can copy that We can create a one more folder and copy it, but just leave it. Let's go to the HDFS, whether I created the folder specific to HBase MapReduce program. I must already 50070. Yeah, this is what we talked about is the HBase location. You're already aware because that's a standard we have been following. And in HBase, we always follow the standard programs. So whatever the programs we are writing, everything is in this folder. And one of the folder is HBase MapReduce. This is what I'm trying to say. I think HBase MapReduce. This is already copied into HDFS. So the something I have not maintained the similar folder in my edge node. Probably I will create later only for just consistency, because this is not the new folder, new file I'm using. Basically one of the existing already used in other examples, employee.csv, right? And we always follow a standard. It's an input and an output, right? This is what we write our out, whatever the output of our MapReduce program, we write it into output program folder, and the input is basically this location. That's the standard we have been following for each and everything. So this is all different the programs we have written, uh, just basically MapReduce programs. So let's go to that file once, but I think that file is, I think, let me open that file. I think I have this file from Hive, I think, ls cd employee, ls cd import. I think all you are aware of this, employee.csv. Yeah, probably not this. Yeah, I think it's a very simple file. I think we can read it from here. Let me read it directly from Hadoop. Hadoop fs minus cat HBase MapReduce input Hadoop fs minus cat, coming twice. Yeah, I mean, this is the data. It's basically comma separated file. What I have is an employee ID, employee name, salary, and department number. It's a pretty simple file, right? Because you don't want to make a complex files here, just you have to understand the concept. So this is basically I will use as my input file, right? And basically I will insert this data into HBase table using HBase MapReduce program, right? And here my input format is text input format. Probably once I go to the source code I will explain, but I'm using a text input format where key is the byte offset and the complete row will come as a value, right? Everything will come as a value. So when I parse it, my value as the entire row, then I have to parse it appropriately by a comma as a delimiter to get the employee ID, name, salary, and department number, right? Let's go to this program now, right? We write a mapper class first, right? That parse the data, and our data is basically input file is an employee, which has a 4 columns: employee ID, name, salary, and department number, right? That's basically the mapper. Let's go to the mapper class, right? we get a long writable and text writable, so text as an input, because our input format is a text input format, right? Because my input format is text input format. So this is consistent. So getting long writable and text. My output format is basically HBase file output format, right? Which emits an immutable byte writable and a put. Put is basically, we have seen kind of a row. Now, we define a row basically using a put. I think we have already we add one column. Basically, it forms row key, column family name, column name, and then value. So when you emit, you will emit the put as a value, right? It's a pretty simple thing. So our input is long writable and text, right? And here the value is a text is a value. In a text input format, we get the entire row as a value. So I am, each column is separated by comma, so I'm splitting by comma, right? Just I'm adding it now, right? I'm adding in my key, I'm just taking the first column as my key, right? Everything we have to convert into a bytes, because in HBase there is no data types like int, log, text, whatever, so on, so nothing like that. So what you have is everything is presented as a bytes. So I'm converting everything to bytes using the this class hadoop.hbase.util class called bytes, right? Bytes.2bytes. First column is basically my employee number. Um, I'm adding to a basically a employee number column, employee name, salary, and department, right? Ensure that this table already exists in basically HBase, right? At the end, it's as usual context.write. I hope this is pretty clear. Our input format is text input format. So what you have is long writable and text, and the output format is htable output format, h file output format. So which expects immutable byte writable and put as key and value. So we are writing the key and value, and please pay attention here. Everything is of type 2 bytes, right? And the driver, right? So I think everything as of here, everything is pretty straightforward. And as we aware, we are setting the map output key and map output value class. That's in line with my output format, which is immutable, byte writable, and a put, right? This is all standard, my input path and output path. Here I am setting some configurations for the connecting to Zookeeper. I'm running in a local host and it's a port number. That's what, when you talk to HBase, basically we connect to Zookeeper, right? And I'm giving the port number and where the IP address, it's a local host here to connect to HBase. And I've created an EMP HBase table, right? And I am loading it into this table, right? It's all the table is basically is loaded into H table, right? At the end, we have to do a bulk load. So everything is returned to this H table. Probably you can see the output format as well, right? Let me check. I think I've already ran the program. You see the output format. You can always check it here. Yeah, see, I mean, that's what pretty important. I think we have talked about it when talking about the theory, right? It's structured the data, that it stored the data in such a way that each column family has a separate data. I think I've done the bulk copy. Otherwise, you could see the data because we finished the basically bulk copy of the program, a professional, right? So basically, the data will be organized in such a way that all the personal data, the column family data, will be stored together. That is why basically personal it has created a separate folder, professional it has created a separate table, right? The data from here is basically I think got deleted because at the end what we are doing is we are loading the data, right, into my table. At the end, once everything is written to this folder, my output format, we load the data using incremental load to this file, right? So to this table. So because of that, probably I think data is uh, not showing in those folders. So let me delete that, because if the output file, usually in our programs, what we do is we always delete the output file. Take anything, let's say a word count program, we always delete the file, but in this case I'm not deleting, right? What we do usually, what we do is we always delete the output file before running our job. If you don't do that, if the output folder already exists, your MapReduce program will fail, right? In this case, I am not deleting it, probably to get rid of not deleting this output folder every time you run it. Probably we can handle this deleting this output folder. As I'm not doing in this case, let me drop that folder, output folder. Hadoop, Hadoop fs minus rm minus r, paste it. Yeah, delete everything in this output folder. Yeah, I think everything got deleted. Personal, professional, success, everything got deleted from this. Now I think we can run this program, right? We know about the input file. I think we have gone through everything. So basically, the only difference here is we are writing to a H file output format, and we are giving a connection to the zookeeper, and we are loading this data in the format of H table, right? When you configure into H table, based on H table column family, the data will be stored in that specific format in HDFS, our output path. Once it is stored in output path, we just do a bulk load into HTML, because this what the way the data is organized is the way it should for this table, which is having basically um, uh, two columns. I think professional and personal as a column family. It reads that basically metadata, and it organizes the data into output file in that format. Once data is there, we just load it to this folder, right? So permanently load it to HBase table. So once that is completed, data will be removed from this output format, because we are doing a bulk load into H table, right? Now, I think we always follow same standard. Run as maven clean, maven install. I've copied the file into this location, our usual location, home HT user, applications, right? For this, all our programs write it here. I think HBase MapReduce, right? HBase MapReduce. CD HBase MapReduce, right? ls, and this is the file. I think let me check. I think I've already ran it. uh, just copy that, probably that's easy rather than running it. History and grep. Excuse me. uh, yeah, and this is the, let me copy and paste it here. Where can I paste? I think applications. accessories, the text editor. Right, Hadoop jar, and this is my file, and the syntax is different here. I think if at all we want to add, I want to add some configuration file related to HBase. Uh, so I can add using libjars, right? We can add using libjars. So same Hadoop jar, the jar file name, and the complete class file name, and whatever the jars you want to add, you can add it here. So basically, I am adding all the jars for HBase related ones, and once it is added, we have our arguments. Our arguments is the input file with the location of our input and the location of our output, right? And the table also I am using EMP HBase, right? What's EMP HBase? That table should exist in HDFS, sorry, HBase, right? The table is already there. We can have a quick check as well. List, right? It has a table called EMP HBase. So data will be inserted into this table, right? And we are in this location. Now I can run this Hadoop jar, right? Let me run it. It oh, program MapReduce already exists. I think we deleted. We have deleted that folder. Okay. I think when I've deleted, I think okay, HBase MapReduce. Okay, under output I've deleted. I think I should delete this one as well. Right, output also deleted now. Let's quick check. I think we have deleted only the folders under output. Output, now output is not there. Folder, just run it now. That's what, not, I think all our earlier programs, right? Basically, we are deleting in the code itself as a part of a program in the program itself. Now I have not deleted. What we have done earlier is under output deleted, but not the output folder. Now I think it's deleted, so it should work. This is basically Zookeeper 2181, the port number. It's running the job. Yeah, this is Hadoop HBase MapReduce program. So we can track everything in this resource manager. Earlier, I think in other session, we talked about HBase Java client that runs within the machine, but here it runs within Hadoop cluster, right? Use a MapReduce. So you can see MapReduce output, everything is done and it's copied. But I think these files won't be here. Output folder will be there, right? It's organized, but these files, because at the end we are moving this data into H table, probably these tables data will be uh, removed from this location. So this from this location data will be inserted into H table. Right? Now go and see our H table. Right? It's an EMP HBase, and our data is, I think we have seen our data earlier. Our data is, I think yeah, I think here we go, right? This one, right? This is our data. I think 10,000 Venkat, 10,001 Srinivas, whatever. So all this data should be inserted into our HBase table. We will see that. Uh, right? It's EMP HBase scan. emp HBase, right? See, all this data, whatever is there, everything got inserted, right? I think employee ID, employee name, department number, salary, so on and so forth. So all the data, whatever is there in our H file, input file, all got inserted into our HBase, and it has 8 rows, and here also it should be having 8 rows, right? Yeah, I think 8. I think probably you can check that. It's a good thing. Here, whatever happened. Here it might be having 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? But I think this key is repeated, right? Probably in case of Hadoop file, there is no PK and all. It will have all the 9 records. But in this case, here basically as we are defining the row key, right, this will override the value. So if you see here, it should be 1005, right? It should have written like this, right? 10. See, it's as updated with this Neha record, right? See, that's what has happened, I think, right? So go here and 70,030, right? 70,030. That's the difference between even HBase and just HDFS file. Here we have a kind of a PK. Row key is the unique one, as it's repeated twice, right? It has updated the Saurav record with the one which is already repeated. Probably I should have put 1008, but I put the same thing. I think that's good. In fact, here it's forward return, so it has only 8 rows here, right? Yeah, I mean, that's about basically Hadoop HDFS MapReduce program. So here everything runs within HDFS. You can also quickly check it by going to this URL as well. Right, we can see it here because it's an HBase MapReduce program 8088. Right, the jobs HBase job name, that's what we have run now, right? That's the difference between HBase Java client and HBase MapReduce program, where it runs sorry, within a Hadoop cluster. Yeah, I think, yeah, I mean, that's it. I think thank you very much. Thank you very much. If you have any questions, anyhow we can discuss in the class. Thanks.